Warahmatullahi wabarakatuh. Selamat pagi semua. Good morning, everyone.
Good morning, Doktor.
Okay, apa khabar semua?
Baik. Sihat.
Yeah, Alhamdulillah. Okay, so we have now 34 students online. Okay, anyway, I will proceed. We'll proceed with a lecture now on 6S, which is on statistical process control. Okay, so today we have a class until 12:50, right? Okay, can someone quickly refresh again or recall back what we did last class related to quality, topic on quality? I plan to finish this topic for today.
Last Sunday we did discuss about cause and effect diagram.
Okay, good.
The example given is for high accident rate.
Okay,
And next we did discuss about flowchart, some
okay,
symbols related to flowcharts,
okay.
and we ended with a bit of statistical process control.
All right, very good. Tanesh, okay. I would like to ask Akmal Darwisi. Okay, can you continue what we discussed related to control chart? We briefly discuss related to statistical process control. Yeah, Akmal.
Yes.
Okay, can you quickly share with us what we did on statistical process control with respect to control chart?
Yes, we learn that the purpose of the control chart is to help distinguish between natural variation and variation due to assignable causes.
Okay, so we discussed about what is natural causes and assignable causes, right? Okay, what else?
That's all, I think.
That's all? Okay, Aiman Hakim, what is the difference between assignable causes and random causes? What is the difference? Aiman, are you there? Your name is there. Okay, anyone please? Amirul? Okay, Aiman. Oh, dia tak jelas dia kata. Okay, mungkin lain problem. Okay, then Amirul. Okay, what is the difference between assignable cost and random cost?
For natural variation, for natural and assignable causes,
Yeah.
natural causes known as common causes, and it affect almost every process that are to be expected.
Okay.
For assignable causes, also known as special causes, the objective is to discover when assignable causes are present.
Okay, very good. Okay, so we use control chart. We use control chart to differentiate. Okay, to differentiate between assignable cost and random cost. Okay, random cost. Sometimes we call it random cost. Sometimes we call it natural cost. Is the same. Okay, so when we have random cost or natural cost, meaning that the process has no problem. The process is, we call it statistically in control. Okay? Process is statistically in control when there is only random cost appear in the process. But when we have unnatural variation, okay, we call it due to assignable cost ataupun cost sebab yang boleh ditentukan, sebab yang boleh ditentukan. So the meaning is the process is statistically not in control. Process is having problem. So the purpose of doing control charting is to differentiate between these two, whether process is statistically in control or process is statistically out of control, or we call it due to assignable cost. Okay, now I'm sharing with you the textbook where you're supposed to read page 246 until 262 related to this topic that we are discussing now. Okay, just let me quickly go through this. You see the textbook now, right? I'm sharing with you now. You see that or not on the screen?
Yes, Doctor.
Yeah, right. So this is supplementary, supplementary of the chapter 6. Chapter 6 has two. One is the main chapter covering the basics SPC tools that we have discussed on fishbone, histogram, we have discussed about Pareto, check sheet, and so on. Supplement 6 is focusing on statistical process control. In particular is control charting. Okay, and control chart, that's what we are going to discuss now. Okay, so on page 246, okay, so we have statistical process control and we are focusing here on control chart. Okay, control chart. This is the control chart. And as I just reviewed with you just now, is natural variation. You can read there what is natural variation. Okay, natural variation. We just mentioned that. Okay, so if we plot it in terms of histogram, okay, you can see, okay, the differences between natural and assignable variation. Natural means random variation. Assignable means the process is having a problem. Okay, it's having a problem. So from the histogram, we can see the shape, okay, the shape of the process. So when we take enough sample, we will see the shape. Okay, if you see number D here, okay, number D, this is natural causes of variation. So meaning that the process has no problem. Okay, the process has no problem for the shape showing on D. But there will be a problem on E. Okay, the shape of E, there is a problem here. Okay, because the mean shifted, the mean of this distribution shifted, and also the standard deviation also changing. It changed. So it's very serious problem in this case. Not only the mean changes, but the shape or standard deviation also change. Okay, so the best is we want it a very small standard deviation. Okay, to show the consistency of the values. Okay, so further on in this topics is talking about, you can read, okay, you can read this to get better understanding what is assignable cost. And also when we do control charting, we are taking samples. Okay, we are taking samples. Okay, normally sample will be 4 or 5. Okay, but it here is mentioned that 4 to 8, but normally 4 to 5 is in the practice we take samples. Okay, so okay, okay, let me go through the control charting. Okay, control chart. We have control charts for variables. Okay, control chart for variables. We also have control chart for attributes. Okay, control chart for attribute and control chart for variable. But let's look at control chart for variable first. Okay, X bar chart is control chart for variables. Okay, where the measured value is given in terms of numbers. For example, in terms of weight, speed, length, strength. So if you are producing products, okay, for example, you are producing metal sheet, okay, metal sheet ataupun kepingan logam, that kepingan logam that you may be using this kepingan logam untuk membuat katakan pintu kereta. Okay, I would like to know from your opinion, what will be the critical to quality of that kepingan logam? Okay, can I hear from Diana? If you have a piece of metal piece, you want to convert this piece of metal to make it pintu kereta, what will be the importance quality characteristic for that sheet of metals? Diana, please respond. If you don't respond, please, if you cannot on your mic, please respond to us to the chat box. Okay, what is problem that you are having? If not, I consider that you are not there. Even your name appear. Okay, if you cannot hear me, please respond to the chat board. Otherwise, I consider is not attending the lecture. Even the name and the scan is there. Please, Diana, you hear me? Okay, the house tengah renovate, bising sangat. Okay, no problem. Okay, Ahzad. Okay, Ahzad, please respond to my question.
Hello?
Yeah, Azad, okay, you hear my question?
Maksudnya can you repeat sir sebab saya pun ada ni.
You tengah buat apa tu?
Tak, saya tak jelas dengan Sir punya question.
Okay, katakan you ada sekeping logam dan logam ini kepingan logam, metal sheet. Metal sheet will be used to make car door, pintu kereta. Okay. So soalan saya, apakah ciri-ciri kualiti yang perlu ada pada kepingan logam tadi untuk digunakan untuk buat pintu kereta? In your opinion?
Ringan?
Ringan. Okay, ringan maknanya you need to measure dia punya weight lah. Alright, okay.
Yes.
Lagi? Okay.
Strength.
Strength, okay. So this is something that you're going to test that piece metal sheet tadi dari segi strengthnya. Okay, you may have specification that this metal sheet has to satisfy minimum strength, right? Correct? Okay,
Yes.
lagi?
Cost tu kira dekat ciri-ciri ke sir?
Apa?
Cost.
Okay, katakan you are working for car manufacturer, buat pintu kereta, and then you ada kepingan logam, pintu kereta tu dia buat dari kepingan logam kan? Akan dibuat bentuknya mungkin dalam proses stamping. Okay, so you kata tadi berat. Okay, correct. Berat is one of the parameter kita akan ukur apabila menerima kepingan logam, right? So kalau kepingannya adalah mungkin tidak memenuhi spesifikasi, kita tidak akan terima. So this is what we call it variables, variables that we are monitoring. Okay, you mentioned also dari segi strength. Okay, apa lagi?
Length sir, length.
Length. Okay, mungkin more important here is thickness. Okay, thickness, length pun boleh lah. So these are the values di mana we need to use equipment, right? When you need to use equipment to monitor these parameters, critical to quality, we call it variables. Okay, variables. Semua nampak semua nampak yang saya share. This is from the books, control chart for variables. Nampak ke?
Yes.
Okay. So what I was trying to get is when the parameter need to be measured, okay, using equipment, so we need to use control chart for variables. Okay, control chart for variable will be X bar chart and R chart. Okay, R chart. Okay. X bar chart and R chart. X bar mean we are taking average of values. Okay, R chart mean we are taking the range of value, which is the difference between maximum minus minimum values of the sample. Okay, another type of control chart, we call it attribute control chart. Okay, attribute control chart. Okay, I come back to variable control chart later. Okay, I just want you to understand the concept between attribute and variable control chart. Okay, variable and attribute control chart. Attribute control chart, okay, control chart for attributes. Okay, please read this first paragraph here. Okay, I will ask you, what is actually attribute? Everyone please read. Okay, I will ask randomly after this. What is attribute? Okay, let me ask Ahmad Azizi. Okay, Ahmad Azizi, what do you understand from attribute control chart?
Hello, sir.
Yeah, you read. Okay, please.
Tak payah baca lagi, sir.
Tak baca. Buat apa tu? Tengah buat apa?
Tak, saya tengah baca lah.
Okay, alright. Habis baca bagi tahu saya apa yang kamu faham. Only first paragraph.
Sir,
Okay,
so apa yang saya baca lah.
okay,
Dekat control chart for attributes ni ada dua charts, satu P chart dan C charts.
okay, correct.
Yang P charts tu untuk measure percent defective dalam sampel,
Okay,
dan untuk C chart untuk kira berapa bilangan defect yang ada.
okay, correct. Okay, is there any understanding on apa beza antara attribute and variable?
Kalau attribute, kita nak asingkan defektif dengan non-defektif.
Okay,
Kalau variable, mungkin kita nak asingkan tentang dia punya struktur mungkin. Macam mana dia nak kira dia punya panjang dia atau berat dia ke.
okay, Ahmad Azizi, yeah. Okay, you have some understanding there, but it's not clear. Okay, the difference between attribute and variable. Variable is apabila parameter yang diukur menggunakan peralatan, measured values. For example, thickness. To measure thickness, you need an equipment. Okay, it could be micrometer or any other suitable equipment. To measure the strength, you need also to have equipment to measure, where the parameter will give the values, okay, in terms of numbers. But when we are talking about control chart for attribute, we just only want to know whether, okay, either the pieces that we sample is can be accepted or cannot be accepted. So what we call this inspection, okay, to accept or to reject of that pieces. So the inspection is simpler, does not require specific equipment, okay. In general, does not require specific equipment. Maybe you just make a decision to see some ada defects ataupun tak ada defects. Ada defects, okay, meaning ada kecacatan lah. Ya, ada kecacatan. Kalau tak ada cacat, we accept that. Ataupun we make the inspection, we call it go and no go. Go mean it pass the inspection. No go mean dia tak lepas. So that type of inspection results, we can plot it using attribute. Okay, I can give you example. For example, you are in business of selling fruits. Okay, katakan berniaga pasar malam. Okay, masa PKP ni tak payah balik kampus, tolong parents buat bisnes pasar malam, menjual kotak-kotak yang mengandungi limau. Dalam limau tersebut, dalam kotak tersebut mungkin ada 20 biji limau. So we don't use micrometer, we don't use any special equipment to see whether limau ini buruk atau limau ini boleh diterima ataupun tidak. Just looking at it, okay, just melihat kita dah tahu limau ini masih okay, boleh dijual. Limau ini sudah rosak. Okay, so itu maksudnya attribute. Attribute means sifat, sifat ataupun sifat yang ada pada produk yang kita tengah membuat pemeriksaan. So the decision is either to accept or to reject, rosak ataupun tidak rosak, itu saja. So a very simple inspection is done using when we want to plot attribute control chart. Okay, so okay, it's mentioned here is, for example, when you are doing, for example, defective, involve counting. Okay, just counting only. Okay, kita bilang saja. Okay, or you want to measure for example, defective. Okay, defective in sample. So if we are plotting the percentage of defect, katakan 20 biji limau tadi ada 3 rosak. So 3/20 itu akan menjadi nilai P lah. P maksudnya proportion. Okay, proportion. Okay, ada juga orang panggil fraction. Okay, ataupun kita hanya mengira sahaja how many defects. Okay, how many defects. So if we counting only how many defects, we use C chart. Okay, to represent counting. Okay, I give you more example later on this. Okay, if you don't understand, please ask question as we move on. Okay, I want to explain on the importance of having sampling. Okay, so I did mention last class for you to look into what we call it central limit theorem. Okay, central limit theorem. Can anyone share with the class what you understand about central limit theorem? Okay, you can type in the chat box what is central limit theorem from your understanding. Okay, before I call any one of you. What is central limit theorem? I assume all of you have studied statistics, right, before taking this class? Okay, Irna. You hear me, Irna? Okay, sebelum ambil course ini ada belajar statistik, ya?
Ada.
Ada pernah belajar tak central limit theorem?
Ada.
Okay, apa yang kamu masih ingat berkenaan dengan central limit theorem?
Dia ada macam population mean, standard deviation.
Okay, ingat lagi tak di mana kita gunakan central limit theorem?
Tak sure.
Tak sure. Okay, tak apa. I move on to Edmund Wu Kah Yong. Edmund,
Yes, sir.
okay, what do you understand by central limit theorem? You study statistics, right?
Yes.
Bila?
Last time.
Last time, still new, okay? So you learn about central limit theorem, okay? So what is central limit theorem? Because this is going to be used in quality control. Okay, what is central limit theorem? Dah lupa dah?
Lupa dah.
Okay, tak apa. Okay, now you have to read again. I'm showing to
Okay.
you on the ebook now. You see that what I'm sharing, right?
Yes, sir.
All right. What central limit theorem says, okay, regardless of the sample, okay, that you are taking individually, okay, it could be, okay, I'm showing here now in terms of shape, okay, the shape. Population distribution, okay, nampak ya, Edmund? Okay,
Yes, sir.
nampak ya? Okay, population distribution, okay, we can have beta distribution, we can have normal distribution, we can have uniform distribution. Okay, what are other distribution that we have in statistics? Still remember?
Other distribution.
Poisson distribution. Okay, apa lagi? Poisson distribution lagi?
Binomial.
Binomial distribution.
Binomial.
Apa?
Binomial.
Binomial. Okay, we have so many type of distribution, right? We have triangular distribution, okay, yang bentuk segitiga dan sebagainya. So if you plot it individually, okay, you will get a shape which is according to that type of distribution lah. Kalau normal uniform here, maknanya it has the same chances to have that chances of appearing. Okay, I want to ask you, if you have a coin, I think it's common in the statistic, you have a coin, Okay, ada head and tail, right? That coin have head and tail. Is it correct? Ada kepala dan ada ekor. Okay, what type of distribution if you are flipping this coin? What type of distribution you're going to have?
Binomial.
Binomial, yeah. Okay, because you have only two choice, right? Okay, if you have a dice, okay, dice. Tahu dice, yang ada 6 permukaan tu. Okay, what type of distribution you're going to get if you flipping this 100 times? 100 kali. Anyone, please? Hello? What type of distribution?
Binomial.
Binomial? Correct ke? Dadu tu ada berapa muka? Okay, Bavitiran. Bavitiran. You hear me, Bavitiran? Okay.
Yes.
If you have a dice, okay, you have a dice. You know the dice, right?
Yeah.
You have 1 dot. You have 2 dot on this side. Okay. 3 dot, 4 dot, and so on. If you keep flipping this 100 times, what type of distribution you're going to get?
Normal distribution.
No? Why normal?
Maybe it's 50-50 possibilities.
No, six faces. You're not going to get 50-50. You have
Maybe.
you have number 1, number 2, number 3, number 4, 5, and 6. Okay, 6 dots. Right. 1
Yeah.
dot, 2 dot. Okay, 3 dot, 4 dot. Okay, if you keep flipping this, okay, what type of distribution you get?
I'm not sure, sir. Maybe beta distribution. I mean, like, I really
Not sure.
sir.
But
Yeah.
you have taken statistics, eh?
No, I haven't taken, sir.
Okay, you haven't take.
Yeah.
Why you haven't take? You haven't taken why?
Because my credit already exceeded, so I have to take another semester, sir. Because I got some subjects that I did take.
All right, okay. Okay, I want to ask Daniel. Daniel? Hello, Daniel.
Hello sir, Assalamualaikum.
Salam. Okay, if you flip these dice, yang ada 6 muka ni, what type of distribution you're going to get?
Binomial ke normal
Binomial, kalau coin boleh lah.
Normal lah kot sir.
Why normal?
Saya pun tak sure lah sir.
Kalau normal, bermaksud you punya dice tu sengit lah. Ada central tendency, berada certain number will have tendency to appear more often compared to others. Okay, secara teorinya, kalau ada 6 muka, kalau you flipkan 100 kali, what is chances to get 1 dot?
Over 6.
1/6, right? What is the chances to get number 2 dot?
1/6 juga.
1/6. Okay, what is chances to get 3 dot?
Over 6.
1/6, right? Assuming your dice is perfect, tak ada sengit-sengit, Kalau you kata normal distribution, it will be sengit lah. Sebab the dice tak sengit praktis ni. Sebab dia adalah square, ada 6 faces. Okay, kalau untuk 4 dots, berapa chances to get?
6.
1/6. So maknanya semua 1/6, right? 1/6 chances to get that. So it's going to be all uniform. Okay, you have 1 dot here, 2 dot here, okay, 3 dot here, 4 dot, 5 dot, 6 dot. Everyone follow me? You have equal chance to have that the dots that you have there. Okay, but okay, if you are flopping not a dice, but if you are measuring, let's say you are measuring, you take a paper, okay, A4 paper, okay, let's say you take A4 paper. Now you want to measure what is the length of this paper. Okay, you take 100 pieces of that paper, you keep measuring what is the length. Okay, how will be the distribution of that length that you measure? Maybe the first measurement you take, okay, 10 cm. Okay, I just give random number. Maybe the next one you take 9.9 cm. Okay, maybe the next one will be 10.1 cm. Okay, you're measuring this A4 paper. Just you want to see whether the cutting process is good or no good. Okay, until the last one, after 100 paper, you will get this one is 10.2, right, for example. If you are now plotting this number, what type of distribution you're going to get? Okay, Diana. Okay, anyone, please? Okay, Wu, Edmund, Wu.
Normal distribution.
Yes, now you understand. This is normal distribution because why? We have a target for this paper, right? We have a target that this paper might be a little bit small or a little bit larger. It will be normal. So you have what we call it central tendency. You got what I mean now? Okay, there are few paper which is smaller than target. There are a few paper that will be slightly bigger. So we have a target. So this is normal distribution. Everyone, you understand what I'm saying now? Hello?
Understand.
Okay.
Faham.
All right. So if you have a target, okay, the chances for you to get will be normal distribution because the mean will be your target. But in terms of dice, do you have a mean or not for dice? If you are plopping a die, do you have a mean? No, you don't have a mean that is like measuring a paper. You will have equal chance to get all of the faces because your dice is even. Okay, equal face. Dia tak sengit. Unless your dice is sengit, you will have tendency to be flip on one face, specific face. Okay, so now okay, you know that after we taking sample enough number, we can plot into distribution. Okay, back to the central limit theorem. Central limit theorem is saying that okay, okay, if you take average of the values regardless of the shape of individual values, you're going to have normal distribution. What is plotted here in the population here, okay, in the population that's individual value, okay, meaning that you measure one by one and you plot all that according to frequency of that value. You remember you did for the height and weight for the class? Okay, I give you assignment on that last time. That's where you are plotting the shape. But that shape have average values. Okay, what is the average value for the height and the weight for the class? That will be normal distribution. Okay, that will be normal distribution. Okay, but central limit theorem says there are situations where a measured value is not coming from normal distribution. For example, it's coming from uniform, or it could be coming from skewed beta or triangular and so on. But when you take the average, okay, the average of those values in terms of sample size with enough number of subgroup, okay, you are plotting the mean. Okay, plotting the mean. See here, distribution of sample mean. Okay, let's say you are taking, you say, I want to flip this dice, okay? Let's say I want to flip it 100 times, but I want to measure every time I want to add 5. Let's say I flip number 1, I got, okay, let me clear this part so that I have more space. Let's say I want to flip it 100 times, but I want to plot the average of 5 values. Okay, the average of 5 values. So meaning that I will flipping the number. Okay, so let's say number 1, I will flip. Okay, I will get okay, maybe number 1. After that, I will get number 6. Okay, maybe number 3, number 2. Okay, number 1. So I have 1, 2, 3, 4, 5. Okay, I will take the average, and then I will flip again. Okay, second group. Okay, maybe I will get 6. I get 3. I get 1. Maybe I get 1 again. Okay. So now I have 1, 2, 3, 4. Maybe I flip again. I got 3 again. So I take the average. Okay, I continue until let's say 20 times. Because why? I just want to have that values. Okay, I can. If you have minimum 20 subgroup, this is subgroup. We call it subgroup. Okay, subgroup. All these are subgroup. Okay, so now you are measuring the averages of that subgroup. Okay, what is the average of sample 1? Please give me the number. 1 plus 6 plus 3 plus 2 plus 1.
2.6.
2.6. Okay, you get that 2.6 as the average. Okay, about the second one? 14 divided by 5. What do you get?
2.8, sir.
2.8, right? Okay, so if you continue in doing it until 20, let's say I give a random number here. Maybe I say I got 3 here, I got 1, I got 2, I got 2. Okay, maybe 3. Okay, because I just flipping randomly 5 times. Okay, what do you get the average here? $11 divided by 5. What do you get?
2.2.
2.2, right? 2.2. Okay, let's say I have now 20 numbers. Okay, because I have subgroup now is 20. If I plot this number, the averages, this is the average of the subgroup. Okay, if I plot it, what will be my distribution? I plot the average, or we call it sample mean. What distribution will you get? Okay, Jihan say normal, correct. Okay, sample mean. If you plot the sample mean, even though originally it was uniform, but you plot sample mean, you will going to get normal distribution. Okay, you get normal distribution. Even if the individual value was coming from triangular, let's say it's triangle. Let's say the distribution is triangle. But if you take the averages, you still get this normal distribution. This is what is said by central limit theorem. Okay, central limit theorem. So it's very important in quality control, we plot the average values. Okay, so we have it here. It says that, okay, the theoretical foundation of X bar chart is central limit theorem. Okay, make sure you understand what it is. The foundation of X bar chart is central limit theorem. Okay, this theorem says that regardless of distribution of population, distribution of X, XS ni bermaksud the averages, okay, of a sample drawn from this point tend to follow normal curve. Okay, so fortunately, even if sample n is fairly small, let's say 4 or 5, the distribution average will still roughly follow normal distribution. Okay, everyone clear? The central limit theorem? Okay, so this is very important because in control charting we always refer to X bar chart. So we can make estimate that. Okay, you need to be familiar that sample distribution standard deviation X sigma X bar. Okay, population standard. Okay, sorry. We estimate the averages. Okay, X double bar. Okay, will be the mean. Okay, the mean for the population, and we can also estimate that. Okay, the population standard deviation. Okay, X here. Sorry, sigma X bar. Okay, will be the population process standard deviation, which is the individual. Okay, the sampling distribution, which is sigma X bar, is coming from population. Okay, sigma here is population. Okay, population standard deviation divided by square root of n. What is n here? In the previous case, I use n equal to 5. So n will be the sample size. Okay, the 20 numbers that I used just now was subgroup number. Okay, everyone clear or not with that background? Hello?
Yes, doctor.
All right. Okay, having understanding that, okay, now let's say you have taken the averages of individual value, you will get normal distribution. Now you need to understand the coverage of this value. Okay, we have sigma just now. Sigma means standard deviation. Everyone understand standard deviation? I think you have learned somewhere, maybe in high school or somewhere, if you have not taken statistics. Sigma means standard deviation, how it is deviated from the target value or the mean values. Okay, so these values, okay, we can refer to the target value, which is our mean here in this example. Okay, the mean here. Okay, so this is the mean. This is the target. Okay, how it deviate? It deviate to the left, sorry, to the right and to the left. If it is deviate, okay, between plus minus 3 sigma, we say plus minus 1 sigma, the value within this range, okay, coverage of that plus minus 1 sigma, okay, it will be about 68%. Okay, 68%. But if the coverage is plus minus 2 sigma, okay, it will cover from here to here. Okay, this is I'm shaded in this way. So this is coverage of plus minus 2 sigma is going to cover 95. Okay, 95.45%. Okay, plus minus 1 sigma is about 68%. Okay, we can see the exact value. I think somewhere in the books. If you are talking about plus minus 3 sigma, this one, the coverage is 99.73. 99.73% of area under the curve. So in quality control, we always refer to plus minus 3 sigma because why? We are covering the normal distribution, which is random distribution. Statistically, processes are stable if they are within plus minus 3 sigma. Okay, so which is covering 99.73% area between plus 3 sigma X bar and minus 3 sigma sigma. Okay, up to that point, anyone? Okay, I hope that is clear. That is clear. You can also follow these books here saying that, okay, we have that background of that. So, of course, the as the n values, okay, as the n value increase, you can get smaller values of the standard deviation, dispersion. But if your n is only 25, okay, you can see that is very big. So if you take for just now that I take is n equal to 5, okay, the small value, I mean acceptable value for control chart. But if I take it n equal to 10, of course I will have a value of, you know, smaller, I mean less fat lah. Okay, so that's the background. Okay, moving on to the control chart. Okay, moving on to the control chart. So we have, this is what we call it X bar control chart. Okay, where the limit is, we call upper control limit, which is the central line X double bar plus Z, okay, sigma X bar. Okay, lower control limit will be X double bar minus Z minus Z sigma bar. Okay, I give you 5-minute breaks before I proceed. Because before I can proceed, I need to discuss standardized normal, because that will be useful in understanding what is Z. Okay, standardized value. Okay, anyone has any question before we take 5-minute breaks? Hello? Any question?
Clear.
All right,
No,
take 5-minute breaks and I come back with normalized standard deviation and we move on to X bar chart, R chart and so on. Okay? Boleh, huh?
boleh sir.
All right, thank you. 5 minutes, huh? Okay, so before I proceed with control chart, let us understand standardized normal. Standardized normal. Okay, in standardized normal, normally what we put it and okay, and okay, the mean will be 0, standard deviation will be 1. Okay, this is how we write standardized normal. Standardized normal, where is the mean here? The mean will be equal to 0, standard deviation is equal to 1. Okay, you may have whatever distribution mean and standard deviation before that, but if you want to convert to standardized normal, we use it Z transformation. Okay, will be equal to X, okay, X, okay, maybe in this case we call it X, the mean, the X, okay, if you are taking the mean, okay, the basic formula is X minus mu divided by sigma, okay. So if you are taking the mean, maybe the X here will become double X, and this is the mean. So whatever values that you have, okay, on the X, let's say here is the mean. Let's say I'm using here is the mean. Let's say I take it the mean here. Don't confuse with the symbol. Let's say I use this is double mean here. Okay, I just want to convert what is the standard one. Okay, so will become okay. The values that you have, let's say the target also 10. The target is also 10. Will be 10. Okay, so let me just generalize this. You may have also something like this, minus the mean and minus the mu there, just to get the Z value. So 10 minus 10 divided by 2, you're going to get 0, right? So this is showing that the 10 here will become 0. Okay, the 10 here will become 0. Let's say another value. Let's say you are doing for another value. Hello, you see my PowerPoint now or not? That I'm writing.
Yes.
You see what I'm writing? Okay, all right. Okay, let me put it on different values. Oops. Okay, let's say you have a distribution of, okay, let's say your target value is 10. Okay, but your mean here, okay, the mean here, double bar there become 10.5. Okay, 10.5. And your standard deviation, the standard deviation for this one, you may have, let's say, 1.5. I just pick a random number. So now I want to convert these values, okay, to standardized normal. Okay, to standardized normal. Remember that a perfect standardized normal will have n. Okay, we normally write like this. The mean will be 0 and the standard deviation will be 1. But in this case, okay, so I'm going to have z equal to x double bar is 10.5. My target value, which is the mean, okay, which is 10, divided by standard deviation. So what will be my z value? Please, someone calculate this. 0.5 divided by 1.5.
0.33, sir.
Okay, 0.33, yeah, 0.33. So what it's saying now, if you have that normalized distribution, if the center is 0, now your value is somewhere here. Okay, 0.33. Okay, 0.33. So this is z value. Okay, this is z value. Okay, so this z value will be useful when we are discussing on to see that what will be the distribution. Okay, this distribution of sample under the curve. Okay, under the standard curve. Okay, okay. Let me give you another example. Okay, let's say we want to see area under the curve. Okay, area under the curve. Okay, let me go back to your textbook, because at the end of your textbook, okay, okay, I want to share with you now the textbook. Okay, not this one. Okay, I don't want to share this one. Stop sharing that. Okay, you see the textbook now? Yes or no?
Yes.
Hello?
Yes,
Okay.
Doctor.
Go back to the end of your books. Okay, the end of the book there is appendix. Okay, there is appendix. Okay, in this appendix, we have a table. We call it standardized normal table. Okay, standardized normal table. Okay, I'm not sure which appendix. You can, anyone found that or not? Because everyone has this soft copy of the books, e-books. There is a table, standardized normal table. Maybe appendix 10. Okay, this is 5. Bibliography. Okay, this table. Appendix, I don't know, they call it I. Okay, appendix 1, normal curve areas. Okay, normal curve area. Okay, you have this normal curve area. Appendix I will be used in control chart. Normal curve areas. So, okay, if you see here, this is what I just discussed just now. If you have normalized table, okay, which is the middle will be 0. Okay, so if we look at this, actually this table is coming from Z. the formula that I just mentioned just now, coming from Z, which is Z equal to X minus mu divided by sigma. Okay, normalized table. So the middle will be 0. So let's say we want to get what is the area under the curve, which is this area. How much is this value? We know that area under the curve is equal to 1. Okay, so when Z is equal to 0, okay, you get here Z equal to 0, we'll have 0.5. Okay, so this area is equal to 50%. 0.5 means 50%. Okay, everyone, you understand now what I'm trying to say to you?
Yes.
Faham,
Okay.
sir.
Okay, let's say I want to know now what is the area under the curve when you have 95. Okay, let's say you have sigma. Okay, when you have Z equal to 2, what will be the area under the curve when Z equal to 2? Z equal to 2. Let's say you have this curve. Okay, we know that here is 0. Let's say here is Z equal to 2. Okay, now I want to know what is the area from here to the left. Okay, statistically we will say that. Okay, statistically we will say that this is probability. We want to find the probability of Z less than or equal to 2. Okay, so from this table, okay, can someone tell me what is that value for P Z less than or equal to 2? Okay, graphically, if I want to draw, it is say, if I want to draw, that is actually showing the value. Okay, that is showing the value of this normal distribution where the Z value is somewhere here. Okay, the Z value here is 2. So I want to find the area to the left of this curve. So what will be the Z value?
1 minus 0.57926.
1 minus, so you have, what did you say just now? 1 minus what?
1 minus 0.579
0.5?
57926.
57926. So it doesn't say correct, huh? It's not correct. Okay, where do you get this value?
Oh.
From where?
Dekat
It's
table
not-
tu.
Okay, kat mana tu? Row mana?
Oh, Z sama dengan 2 kan?
Z sama 2, yes. This Z sama 2.
Oh. Sorry, saya salah tengok.
Okay, Z sama 2 di sini, ya. Everyone, please. Z sama 2. Okay, so the value will be this one. 0.9. Okay, 0.97725. Okay, so this value showing the area under this curve. Okay, this value under the curve is 0.97725. Okay, another way to say it is 97.73%. Okay, 97.73%. If it is within this, so we look at the curve here. Okay, so this is the area to the left. Okay, area to the left. Okay, if I want to know what will be the area under the curve where we have plus minus 3 sigma, how should I get it, this value? Okay, remember I was saying just now plus minus 2 sigma, plus minus 3 sigma. Let's say I want to get now the value of between plus minus 3 sigma. Okay, everyone, you follow me or not? Hello?
Yes, following, Doctor.
Okay, so now let's say I want it to get the area under this curve. Okay, so this side is minus 3, this side is plus 3. Okay, remember I say that plus minus 3 sigma. So you're going to use this plus minus 3 sigma for control chart. Di mana Z equal to 3. Z is equal to 3 on the left, Z equal to 3 on the right. Okay, so if I shade this curve, okay, I'm going to have, okay, covering between minus 3 plus 3. So what will be this area? Area equal to what? Okay, equal to what? Hello, everyone?
Doctor,
Yeah, what will be the area?
0.99865.
Okay, one thing that you have to remember, now we are plotting now a curve like this, a curve like this. Sorry, I overlap on this one. So I have here is minus 3, I have here is plus 3. Okay, so I still have the remaining, right? This part, on the left, I still have not covering. This part also not covering. Is it correct? Okay, but the values that given in this table is actually giving us P Z less than or equal to 3. Okay, we have this value, okay, which is given here. Okay, 99 point, okay, or we call it 0.996, 9.999, sorry, 863, 865. Everyone follow me or not? Okay, so if we take that, actually is covering up to the end, covering all. Okay, but we still have this portion. We have to minus this, right? Is it correct? If we take it from here, meaning that the area coverage is from this line until the end, okay, which is 0.99873. This is this value. But this one doesn't minus this one, okay, on the left side. So why I say that? Because if you see here, this graph covering all the way to the left. But if I say I want it plus minus 3 sigma, I have to minus that. I have to remove. Okay, I have to remove the part which is, okay, not included in the plus minus 3 sigma. Okay, so okay, if I draw this again here. Okay, so what you have just now, okay, is the area from here, okay, anti-finish, okay, anti-all. So this area is, okay, which is plus 3 here. Okay, from the table, this area is represent 0.998. What was tadi? 6 berapa? 865. Okay, 865. So how can we also exclude this portion of this part? Okay, I need to remove this part so that I will get the correct number. I need to minus what? Hello?
Minus to the 1 minus 0.99865.
Yes. So this area, okay, correct, Fahmi, So this area is actually 1 minus 0.99865 because we just opposite of this value because we have this part and we have this part. Okay, so that will be what is the value here? 0.99863 minus. Can someone give me the number? 1 minus 0.99873. So you're going to have 0.00135.
135.
Okay, so if you want to know that plus minus 3 sigma, the range of this value within this range, so we have to minus that 0.00135. Okay, what is the value after we minus this? 0.99865 minus 0.00135. Okay, what value you get? Hello?
0.9973.
Okay, you going for 99.73. Okay, 9.973. Oh, another way we can say 99.73%. Okay, so that what I was telling you earlier. If we have plus minus 3 sigma, this will be the coverage of the values under plus minus 3 sigma. So if we go back to our earlier discussion, okay, let me switch the sharing of the slide here. Okay, okay, you see now PowerPoint now? Yes or no? Hello?
Yes, sir. Nampak.
Nampak PowerPoint ya? Bukan buku PowerPoint. Alright. Okay. So remember that I say earlier plus minus 3 sigma. Okay, it will cover 99.73, 99.73. So okay, it's not showing here, but in the books, okay, in the books, okay, this one, right? This one. Okay, now you have plus minus 3 sigma is 99.73. Okay, you see the minus here, plus here. Okay, so this is what we call it Z equal to 3. Okay, Z equal plus minus 3, plus minus 3. Everyone understand now why we use 99 points Z plus Z equal to plus minus 3, because we are covering almost all 99.73 area under the curve. Okay, so if the process any values fall within this range, we consider that it's natural variation. Okay, we consider it natural variation. So how can we implement this in control chart? Okay, how we can implement this in control chart? Okay, we move on. Okay, so this is the Z value here. Okay, the Z value that we have here. Okay, so we have x double bar minus z sigma x bar. So this is, we call it upper control limit. Okay. Sorry, lower control limit. Okay, lower control limit. When we plus, we call it upper control limit. So if we plot it in control chart, we have a line like this. Okay, this is another line, another line. So we will plotting the numbers. Okay, the numbers of our observation, number 1, number 2, number 3, number 4, so on. This is will be the mean. Okay, x double bar. So when we when we look at the upper limit, we call it upper control limit. How do we get upper control limit? Is x bar plus 3 sigma. Okay, this is z sigma, which is 3 sigma. When we move down, it is x double bar minus 3 sigma. Okay, this is the concept of control chart. When we plot this, let's say we are plotting this as a normal distribution. Let's say I want to plot it. I can plot it, but my curve will look like this. Okay, the center will be here, upper control limit will be here, lower control limit will be here. Okay, so this will be the coverage of the point that is plotted. Okay, so this is the basis of control chart. We use Z here will become 3. Okay, this also 3 as a control limits. Okay, so these are the value, the mean value. The Z is again just for the purpose of determine control limit. Sigma x. Okay, sigma. Sorry, actually this is sigma x bar. Sigma x bar. Sigma x bar. You need to understand this formula, sigma x bar, because we are taking sample. Okay, for x bar chart will be the population divided by sigma population divided by square root of sample size. Okay, n is sample size, meaning that how many sample you take for every time to get the x bar. Okay, to get x bar. So what is x double bar? Okay, let me add a new slide there. Okay, if I may plot here. Okay, maybe change the color, make it this color, maybe better. Okay. So for the, this is, I'm talking about X bar chart, X bar chart. X bar chart. Okay. X bar, this is variable control chart. Remember at the beginning we say variable, where we get the values from measured values. Okay, measurement value. Can be thickness, can be length, lebar, panjang, tensile, and so on. So this will be the X double bar. Okay, X double bar, which is the mean, will be the average of sample number 1 plus the average for sample number 2, subgroup number 2, plus so on, so on. And then maybe let's say I have n equal to 5. Okay, I may have G, which is the subgroup number, maybe 20. Okay, 20 subgroup. So this one will be X bar 20. So I will be divided by 20. This is how I get the central line. Okay, so G means subgroup, number of subgroup. Okay, number of subgroup. Okay, what is N? N is, we call it sample size. Sample size. So what is X bar? Let's say X bar 1 is the value that you are observing. The value that you are observing in terms of, okay, X11 plus X12 from the subgroup from that subgroup which is 5 sample. Subgroup 1, 5 sample, and then you divide by 5. Okay, so if this is subgroup, okay, this one maksudnya subgroup 1, sample number 5. Okay, if 1, 5 lah. Subgroup 1, sample 5. So that value come to here. Okay, so if you are plotting this on the graph here, plotting on the graph here, okay, so you're going to have number 1 here, number 2 here, okay, number 3, until you have number 20 here. Okay, number 20. So x1, x bar 1 here may be a number that you are plotting here. Okay, let's say that number. Number 2 will be this number. Okay, maybe you are plotting here. Okay, number 3 will be here. So we are plotting now a control chart to show how that value of x bar varies. Okay, varies in this control chart. Okay, so we join that number, that values. If any values, let's say outside, suddenly go outside, so showing that the process is out of control. Because why? That value move beyond the control limit. Okay, beyond the control limit. Okay, so far, everyone, are you understanding what I'm saying? You follow me? Hello?
Yes, Doctor.
Right. Okay. So if we have this example, okay, let me show the example here. Okay, the formula that we get it, I think the books is showing a clearer example. Okay, let me go back to the textbook. Stop sharing this one. Okay, let me share the books. Okay, you see the books now on the screen?
Yes, yes.
Doctor.
Right. Okay, let's see this example here. Okay, example S1, and this in this example, we have a weight, okay, of oat flakes with a large production lot sample each hour. Let's say your company is producing oat flakes, okay, oat flakes. This is for your breakfast, and the company is producing the oat flakes. And then every hour you go and take the sample in the production line. You want to say whether this oat is going to do the filling properly in the box or whatever container. Managers want to set a control limit that include 99.73 of the sample means. Okay, does it mean 99.73? Someone please respond to me. What is the meaning of 99.73? Huh? So it means that it will be plus minus 3 sigma. Okay, meaning that process variation will be within that. Okay, the process variation will be within plus minus 3 sigma. Okay, it can varies. Okay, varies maknanya because we cannot get produce exactly the same. Variation is there. Okay, deviation is there. So plus minus 3 sigma because it's 99.73. So randomly select weight 9. So now in this case n equal to 9. Okay, even though we say that n should be 4 or 5, but in this example n is equal to 9. Okay, for each hour, every hour dia akan ambil 9 kotak. Okay, then find the overall mean, okay, using the equation, okay, shown above, okay, to compute the control limit. Hence, the 9 box chosen for hour 1. Okay, so now we are going to get what is the X number 1. Okay, X number 1. Okay, in this case, it's taken 9 boxes. Okay, 9 boxes, and how many sample? I think they are taking, okay, showing here is okay, 12 hours. Okay, 12 hours. Okay, so in this case, it's taking that it is hour. Okay, and then you're going to have X bar. Okay, hour number 1 taking 9 boxes. Okay, what is the average? 16.1 ounce. Okay, this is coming from this value. After taking 9 boxes, you got this value. Hour number 2, okay, is taking again the same thing, taking the same but the different values. He got it 16.8 ounce. Okay, let's say that this production continues until hour number 12 hours working hours. So he take it here, this part. Okay, maybe if you are working from 8 in the morning, hour number 12 meaning what? Hour number 12 will be what time? Okay, 12 hours working in the factory. Pukul berapa kalau start pukul 8? Hello?
Pukul 8.
8
malam.
This is 8 AM. Okay, this is 9 AM. This is 12 PM lah. Okay, 12 PM. 12 PM dia measure juga, dia dapat 17.3. Okay, kalau kilang ini operate longer hours, maybe we can continue lah. Okay, as I said, typically we take up to 20 lah or 25. But in this example, it just give you 12 only. It's okay for the purpose of exercise here. Okay, you will get some number here lah. Okay, everyone follow this number? Yes or no? Hello?
Hey, Doctor.
Yeah, are you following me, what I'm saying now?
Yes, Doctor.
Yes.
All right, so now we want to get the grand average, okay, which is X double bar. X double bar will be summation of all these values. Okay, in this case, only 12 values, 12 values. So you're going to have 16.1 plus 16.8. Okay, continue until you get 17.3. Okay, divide by, okay, going to be divided by 12 boxes lah, 12 hours. Okay, so this is what you get here. Okay, so that will be, okay, this value will become what? This value will become this X double bar. Okay, X double bar, which is the center of this line. Okay, so this is X double bar. Okay, so now what will be the upper control limit? Okay, upper control limit and lower control limit. Okay, remember that upper control limit is equal to X double bar plus 3 sigma X bar. Everyone follow me?
Doctor.
Yes. Okay, so lower control limit will be X double bar minus 3 sigma X bar. Why it is 3 plus 3 minus 3? Because remember we have mentioned that for this value, okay, 3 sigma, we want it 99.73. When it says 99.73, automatically it will be plus minus 3 sigma under area under the curve. Okay, what is sigma X bar? Sigma X bar, okay, so sigma X bar, we have to calculate that X bar lah, okay, which is coming from sigma divided by square root of n. However, remember this is population. This is coming from population. And in our case just now, n is 9. Okay, n is 9. So I think sigma in this case is given somewhere. Is given here. Population process standard deviation is given as 1 ounce. Okay, sigma is given here. Okay, so in order to get sigma x bar, okay, so 1 divided by square root of 9. In this example, okay, this is what you get here. Okay, so 17 ounce is the upper control limit. The lower control limit will be 15 ounce. So in monitoring the process, any value within this range is considered as normal, stable production. Okay, considered as stable production because it varies only within this limit. Okay, so we say that this process is stable until hour number 9, but after hour number 10 is going out, having problem. Okay, this one also having problem, and then it's also having problem. This part is having problem, this part having problem. Why? It goes beyond the control limits. Okay, everyone, you follow me or not? Hello?
So follow.
Yes, all right. Okay, a simplified version of the control limit is, we call it upper control limit. We can simplify this x double bar, okay, plus A2 R bar. Okay, so we can replace this formula here using this formula. Okay, where we get A2 R bar is from table. Okay, lower control limit will be equal to x double bar minus A2 R bar. Okay, so this will be from table. A2 is coming from table. Okay, A2 is coming. R bar is coming from R values. Okay, so this is from table. Okay, so R is coming from the range. Okay, so R bar is actually summation of R1 plus R2. Okay, since you have now just now 12, huh? So become R12 divided by 12. Okay, so what is R? R is equal to, okay, let's say R1 equal to maximum value of R, okay, minus minimum value of R, okay, for sample number 1. For sample number 2, maximum value in R for that sample minus minimum value of that sample. Okay, if you go back to the table, okay, we have the values here. What will be the R for sample number 1? Because this value is given in full to us. What is the maximum value for this subgroup number 1? Hello? What is the maximum value in this put flakes here for sample number 1?
18.
Okay, 18. Okay. So 18 is the highest. So we say this is the highest. What is the minimum? So R1 will be equal to 18 minus the smallest 13. Okay, 13. So you're going to have 5. Okay. So we repeat the same for the second, okay, for the third and so on. So that's where we get the R value. So having that R value, okay, you can use the simplified formula that I showed just now, okay, for the purpose of producing R chart. Sorry, for X bar chart. For the R chart is just plotting the R value, and the center line will be R bar. Okay, center line will be R bar. Okay, So these are basic X bar chart. Okay, I think in this example you have it here. Okay, in this example you have this simplified formula here. This formula also can be used. Okay, where R bar is coming from maximum minus the minimum value. Okay, so this is a central line, and remember that x2 is depend on a2 depend on n value, on n values. Where we get the table? There is a table. Okay, this is a table that we use. Let's say n equal to 9. Okay, a2 will be 0.337. Okay, also got here a2, d4, d3. This will be used for R chart. Okay, that will be used for R chart. Okay, okay, for R chart, okay, you are given here, okay, the weight of the largest, of the lightest, the weight of heaviest. So this is the maximum value. This is the minimum value. For the same example, so this is the R value. So this is going to be R1, R2, okay, and so on until you get R. Okay, in this case, I think different example given, R10. So finally, your R value will be R bar is equal to this one. Okay, in this example, they use different example here. Example S2 is showing this. Okay, super cola bottles. Okay, different example now. And then for the purpose of plotting the chart, okay, using the same procedure that I've explained earlier, this one. Okay, for lower control limits, and we also can produce the R chart now. Okay, produce the R chart where the R chart is coming from here. Okay, this is the control limit for R chart. Okay, so where normally X chart and R chart is used together. They are used together. You have X bar chart, R chart. Okay, so the R value to the upper control limit is this one for R chart. So where this value is actually R bar plus 3 sigma up. Okay, where it is simplified as D3 R bar. Sorry, simplify as D4, D4 R bar. Okay, D4 R bar, this one. Okay, so this one is lower control limit, which is R bar minus 3 sigma R. Okay, simplified as D3 R bar. So D3 depend on value of n. Okay, depend on n from the table. Depend on n. Okay, from the table. So you can look at this table. This table. Okay, so D3 will be this value. Sorry, D4 will be this value. D3 is this value. Okay, so I think I have covered the X bar chart and R chart, the variable control chart. You should be able to do some exercise. I will give on your WhatsApp group later on the exercise for X bar and R chart. Okay, so I will continue with attribute control chart for the next class, and after that we will start with new topics on project management. Okay, any question before we end the class for today? Hello?
Clear, Doctor.
Okay, if there is no question, that's all. And please check your WhatsApp group. Later on, I will give you a few questions for your assignment on XBAR and R chart. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Bye. Sama.